Batteries are just going to be a massive thing. Not that many people appreciate just how gigantic the scale of battery demand is.
Everyone thinks they know what's coming next. Another Tesla car, another round of hype, another so-called affordable EV. But this time, Elon Musk didn't build a car. He built a weapon. The Model 2's new battery isn't just cheaper. It's engineered to break China's $150 billion stranglehold on global EV supply chains. What's rolling out of Tesla's new domestic gigafactories could reset global economics and force every automaker on Earth to rethink their survival plan. Because this isn't business anymore. It's economic warfare. But what exactly is China controlling that makes Model 2 so threatening? The monopoly that nobody sees, China's battery stranglehold, and why it matters. China controls 77% of global lithium refining. That means 3 out of every 4 EV batteries start life in a Chinese processing plant. Sounds harmless, right? But this isn't just about minerals. It's about power, because whoever controls the battery supply chain controls the future of transport. Over the past 2 decades, while the West was busy chasing quarterly profits, China was quietly building the foundation of a clean energy empire. It began with mining deals in Africa and South America, but the real genius move came in refining, the dirty, complex step no one else wanted. China built massive chemical plants, mastered lithium carbonate conversion, and subsidized every ton processed. Fast forward to today, and the world's electric dreams run through Chinese ports. Here's where it gets wild. Let's say lithium gets mined in Nevada. Before it can power a Tesla or a Ford, it's got to take a round trip to China for refining. By the time it's shipped there, processed, purified, and shipped back, it's added around $3,000 to $5,000 per ton in cost. Not because of labor, but because Western nations simply don't have the refineries. That's like paying a tax for your own resources. And leading that empire? CATL, Contemporary Amperex Technology Limited, worth over $150 billion. CATL controls 35% of the world's lithium-ion cell market. Their closest rival, LG Energy, sits at 13%. CATL isn't just supplying batteries. They're dictating terms, pricing, and access. Every major automaker, Ford, GM, Volkswagen, they're all signed into long-term contracts that lock them into Chinese dependency until at least 2028. Meanwhile, BYD, another Chinese giant, is rolling out fully electric cars for under $15,000. Some are even cheaper, $9,000 in domestic markets. How can they do that? Because they own the supply chain. They make their own cells, refine their own lithium, and assemble everything under one roof. Western automakers can't even come close. For them, building a sub-$30,000 EV means losing money. And that's the secret few people talk about. Traditional automakers aren't just competing with Chinese brands, they're competing with an entire national infrastructure, one that's 20 years ahead, vertically integrated, and backed by government funding. So, when Elon Musk unveiled Tesla's new Model 2 strategy, he wasn't just announcing a cheaper car.
I think you mentioned like the speed of the car coming out the other side is like 1 mile an hour or something like that.
Yeah, it's super slow.
You want to speed this up, right?
He was declaring war on that monopoly. The new Tesla batteries, built domestically, refined domestically, designed to break free from the invisible China tax baked into every EV you see on a Western lot. But here's the question. If Tesla can truly go fully domestic, no Chinese lithium, no Chinese processing, how far could the price of the Model 2 actually drop? And what would that mean for every carmaker still chained to China's supply line? The secret weapon nobody knows about. NC05 battery and the hidden testing program. Tesla has been secretly testing a battery since the third quarter of 2024 that changes everything. And no, it's not some wild Reddit rumor or PowerPoint theory. It's real, it's physical, and it's already running tests inside Giga Texas right now. They call it the NC05, the nickel-based compact cell, 5th generation. And it's the kind of breakthrough that makes every other automaker suddenly look 10 years behind. Here's what most people got wrong about the Model 2. They thought the big story was cheaper batteries, but that's only half of it. The NC05 isn't just cheaper, it's the key to unlocking full US tax credits while cutting ties with China's supply chain. According to Reuters and The Information, this cell is part of a secret 4-battery project Tesla kicked off back in late 2024. NC05, NC20, NC30, and NC50. It's the largest internal battery development effort in Tesla's history, and the one project Elon Musk reportedly said could reset the entire economics of energy storage. So, what makes NC05 so different? It's the first Tesla cell designed from the ground up to be 100% domestically sourced. The nickel comes from Minnesota, the cobalt is refined in Texas, and the entire assembly happens inside Giga, Texas and Fremont. That means every Model 2 built with NC05 instantly qualifies for the full $7,500 US EV tax credit. That's something BYD can't touch, and even Ford or GM can't fully match without importing materials from overseas. And here's the wild part. Tesla didn't just build this battery in a lab, they're testing it right now in physical pilot lines at Giga, Texas. Insiders who spoke to Reuters confirmed that prototype modules have already gone through early stress cycles, and the data feedback loop between KO Road Labs in California and Giga, Texas production teams has been non-stop. This isn't a normal R&D setup, it's parallel innovation. When engineers tweak a formula in California, the factory in Texas adjusts in real time. When a weld parameter fails on the line, the material scientists get that info instantly and redesign the mix overnight. That's the hidden advantage nobody talks about. Traditional automakers work in slow, siloed steps. R&D, then validation, then pilot, then production. It takes them 3 years to get from concept to rollout. Tesla, 15 months. They turned what used to be a 5-year process into a sprint. The NC05 battery proves Tesla doesn't just innovate faster. They've built an entire system designed for speed. That's something no legacy automaker, with its rigid hierarchies and endless approval loops, can ever replicate. By early 2026, NC05 enters full validation builds, and by late that year, it becomes the standard cell for the Model 2. Think about that. While other automakers are still planning their next battery, Tesla's will already be shipping. But here's where it gets even crazier. Insiders claim the NC05 isn't just one battery. It's 3 variations in one architecture, 3 different chemistries that could change how cheap, fast, and durable an EV can really get. So the question is, which one of those chemistries could drop the cost of a full battery pack to just $1,700? And what would that mean for every other car maker trying to survive the next wave? Battery roulette. Which chemistry wins? LFP versus sodium ion versus aluminum ion. Here's where the story takes a sharp turn. Tesla isn't making one Model 2 battery. They're making 3. And each one is designed for a completely different kind of driver, lifestyle, and price point. It's not a gamble, it's a strategy. Because while other automakers are praying their one chemistry works, Tesla's quietly turned the EV market into a 3-lane highway. The LFP option, the mainstream play. Let's start with the foundation, the LFP battery, short for lithium iron phosphate. It's not flashy, but it's solid. This is the version most people will get in their Model 2. It's designed for everyday life, commuting, road trips, the school run, all of it. Tesla's standard 53 kilowatt-hour LFP pack costs just around $2,650 to make, with a real-world range between 250 and 280 miles. And if you go for the bigger one, the 75 kilowatt-hour pack stretches that to 350 miles, still costing less than $4,000. Why is LFP such a big deal? Because it's practically unflappable. Traditional lithium batteries can go into what's called thermal runaway when punctured. That's a fancy way of saying they catch fire. LFP doesn't. It stays cool under stress, lasts longer, and needs fewer rare metals. The The cells are also being locally sourced through Tesla's domestic partnership with CATL, meaning supply chains get shorter, costs go down, and buyers benefit directly. It's the reliable, affordable, no-nonsense choice. The sodium-ion revolution. The game changer. Now, here's where it gets spicy. Imagine a battery so cheap that the pack costs just $1,700 total. That's not science fiction. It's sodium-ion chemistry. Sodium is everywhere. Literally. It's 40 times more abundant than lithium. You can find it in seawater, desert brines, and salt flats. Tesla has quietly acquired mineral rights across the Black Rock Desert and Bonneville salt flats, tapping into massive sodium-rich brine deposits in Nevada and Utah. Using solar evaporation, they can extract sodium carbonate for about $300 a ton. That's less than a third of lithium's cost. Performance-wise, sodium-ion batteries hit 160 to 190 watt-hours per kilogram. Sure, they're less energy-dense than lithium, but they make up for it in other ways. They offer a range of 300 to 350 miles, cost almost half as much, and, this is wild, operate far better in freezing temperatures. At minus 20 degrees Celsius, lithium cells lose more than half their power. Sodium-ion? It holds 93% efficiency. So, for anyone living in cold regions, Canada, Scandinavia, northern China, this chemistry is practically a miracle. The aluminum-ion wildcard, the premium future. And then comes the showstopper, aluminium-ion. This is the Tesla Plaid of batteries. High performance, space grade, and borderline alien. Aluminum ions carry 3 positive charges per atom, while lithium only carries 1. That means 3 times the charge movement, 3 times the speed. In testing, these cells have achieved full recharge in 5 to 10 minutes. Not 50, not 30, 10. According to independent tests at the University of Waterloo, the aluminum-ion battery sustains 800 ultra-fast charge cycles without degradation. Energy density clocks in at about 300 watt-hours per kilogram, giving a potential range of 650 to 800 miles on a 53 kilowatt-hour pack. NASA's Jet Propulsion Lab has even certified its thermal stability. No fire risk, no meltdown, even at 500 degrees Fahrenheit. Yes, it's pricier, about $3,100 per pack, but that buys a lifetime battery, over 12,000 cycles, roughly 270,000 miles, with a 27-year lifespan. Here's the genius part. Tesla isn't choosing between them. It's offering all 3. LFP for practical commuters, sodium-ion for cost-conscious buyers, aluminum-ion for performance junkies. 3 chemistries, 3 price points, $13,800, $15,990, and $21,990, covering every inch of the market. While competitors fight over one battery formula, Tesla is spreading the field. It's not an EV lineup anymore. It's an ecosystem. But there's a twist no one saw coming. These new batteries might be revolutionary, but what happens when they plug into Tesla's existing supercharger network? Are the chargers even ready for what comes next? The production plan that changes everything. Timeline, volume, and global domination strategy. Tesla's production timeline isn't just ambitious. It's mathematically designed to destroy traditional automaker competition. And when you see how they've structured it, you'll understand why Ford, Volkswagen, and GM are sweating through their suits right now. Here's how it unfolds. The big reveal is set for late 2025. Tesla's Model 2 global unveiling, complete with its NC05 battery lineup, will likely happen this November. That's where specs, pricing, and first deliveries will be locked in. Then, only 5 months later, in April 2026, the first customers in North America started receiving their cars. Think about that. A 5-month gap between reveal and delivery. Most automakers take 3 years to pull that off. Tesla's plan doesn't stop there. By mid-2026, Giga Texas and Fremont will be building between 300,000 and 500,000 Model 2s a year. Once NC05 moves into full production later that year, those numbers jump fast, 1 to 2 million units annually by the end of 2026. And by 2027, the target is 2 million Model 2s per year, scaling toward a lifetime goal of over 50 million units. That's more than every Tesla model combined since 2008. Here's what makes this so deadly for competitors. Tesla isn't spending billions building new factories or designing new tooling. Lars Moravy, Tesla's VP of engineering, confirmed that Model 2 uses the same structural architecture as Model 3, simplified for mass production. That means no new supply chains, no new capital drain, just optimized reuse. While Ford's still begging suppliers for lithium contracts, Tesla's already building cars in Austin using batteries made 2 buildings over, and the rollout plan is brutal in its precision. North America comes first in 2026, locking in dominance across the US, Canada, and Mexico. By late 2026, Giga Berlin will take over European production with cold weather-optimized sodium-ion cells. Then, 2027 brings Giga Shanghai into the mix, building for the Chinese and Southeast Asian markets. In less than 24 months, Tesla will have a global 3-continent production chain. If that sounds fast, it's because it is. Tesla has compressed a 5-year cycle into 15 months, using modular design, AI-driven logistics, and real-time manufacturing feedback loops. It's not just innovation, it's industrial warfare. By the time Ford and Volkswagen finally roll out their so-called budget EVs in 2028, Tesla will have nearly 2 years of market dominance and supply chain maturity locked in. So here's the real question. How can Tesla keep prices this low when every other automaker's costs are climbing? The answer lies in what Elon Musk calls vertical integration on steroids. And trust me, it's more radical than anyone thinks. The supply chain sovereignty play. Why traditional automakers can't compete. Tesla owns the mines, the refineries, and the factories. Traditional automakers own none of these, and that single difference, right there, is why they can't keep up. Here's what separates the Model 2 from every other so-called affordable EV out there. Tesla doesn't rent its supply chain, it owns it. Every screw, every cell, every grain of refined lithium is part of a vertically integrated empire Elon Musk has been quietly constructing for a decade. And it's not just about efficiency, it's about control. Most people think batteries are built in one place, assembled in another, and then shipped across the ocean. But Tesla flipped the script. The aluminum used for Model 2 isn't coming from China anymore. It's dug up and refined right here in the US. Through partnerships with Alcoa and Century Aluminum, Tesla has reactivated dormant mines in Arkansas, Texas, and Georgia. And that's not some PR stunt. It's an economic strategy. Recycled aluminum from Tesla's own factories costs around $800 a ton. Imported aluminum? More than triple that. The savings start before a single car even hits the assembly line. Then there's sodium, the secret ingredient powering Tesla's next-gen battery chemistry. Musk secured mineral rights to the Black Rock Desert and Bonneville salt flats, where 2 billion tons of sodium-rich brine lie waiting. Extracting sodium carbonate through solar evaporation costs about $300 a ton. Translation? Practically free, practically endless. But the real game changer sits in Texas. The $375 million Corpus Christi refinery can process enough lithium for over 1 million cars every year. Normally, American lithium ore gets shipped to China, refined for thousands per ton, then sent back. Tesla eliminated that middleman entirely. No Chinese refining, no shipping delays, no tariff risks. And this is where traditional automakers hit a wall. Ford's upcoming budget EV, still dependent on Chinese processed lithium. General Motors, same story. That $3,000 to $5,000 extra per battery pack isn't a rounding error. It's the profit margin that makes or breaks affordability. Then comes the knockout punch, the $7,500 US federal tax credit. Because Tesla's supply chain is 100% domestic, Model 2 qualifies for the full credit. Ford and BYD, Not even close. So, after incentives, the Model 2 could start at $12,000, thousands cheaper than any competitor can dream of. And it's not just cost, it's resilience. If China limits lithium exports, Tesla shrugs. If tariffs spike, Tesla wins. If US laws tighten to favor domestic content, Tesla's already compliant. This isn't just vertical integration, it's economic sovereignty. Musk built an entire industrial ecosystem immune to foreign disruption. But the big question everyone's asking is, how far can Tesla push that price before competitors simply can't follow? The pricing breakdown and market obliteration. How Tesla turned cost into a weapon. Here's where Tesla stops playing fair. Every automaker on Earth builds cars to make a profit. Tesla builds cars to crush an industry. The Model 2's price structure isn't a marketing stunt, it's a kill switch. Each tier is engineered not just to attract buyers, but to bankrupt competitors stuck in outdated supply chains. The base Model 2, running on the LFP pack, lands at a manufacturing cost of $13,800. Add a razor-thin margin and federal credits, and the out-the-door price hits $12,000, less than a used Corolla. The sodium-ion version, nicknamed the NC05 Standard Plus, costs $15,990, offering over 320 miles of range, 5-minute rapid charging, and cold weather resilience no gas car can match. Then there's the aluminum-ion flagship, the Model 2 Ultra, with a mind-bending 800-mile range and a price tag of $21,990. That's not luxury EV territory, that's family sedan pricing. And the real brilliance lies in how Tesla makes that math work. Traditional automakers treat batteries as a cost center, an expensive part sourced from elsewhere. Tesla treats them as an asset. Each battery is produced in-house, on US soil, using US minerals. That means no import duties, no 12% shipping tariffs, and no currency fluctuation losses. Every step of production, mining, refining, casting, assembly, happens under Tesla's roof. A single vertically integrated gigafactory generates $1.3 billion in yearly cost savings compared to legacy automakers outsourcing those same processes. Multiply that by 3 gigafactories, and you start to see the scale of the ambush. Ford, GM, and Volkswagen, they can't follow this model. Their entire infrastructure depends on suppliers who demand profit margins of their own. Even if they tried to match Tesla's prices, their costs would swallow them whole. But here's the quiet detail most analysts missed. Tesla isn't maximizing profits on the Model 2, it's maximizing adoption. The lower the price, the more cars sold, and the more data harvested from autopilot, Dojo AI, and fleet telemetry. That data becomes the backbone of Tesla's next frontier: full self-driving networks, subscription energy systems, and grid storage dominance. So, when Elon Musk says the Model 2 isn't just a car, he's right. It's a Trojan horse for an energy empire. The automotive industry thinks Tesla is selling EVs. In reality, it's selling data-powered infrastructure disguised as a hatchback. And the real shock, we haven't even touched on how this car is built, because the Model 2 isn't assembled like a car at all. It's printed. Model 2 isn't a car anymore. It's a global reset button. When it launches in 2026, the entire EV market won't just shift, it'll reboot. China's $150 billion battery monopoly won't vanish overnight, but its grip will fade fast. Legacy automakers won't disappear, but their affordable EV dreams? Gone. Elon Musk just turned domestic supply chains and vertical integration into a weapon of mass disruption. And by the time rivals even realize what happened, Tesla will have sold over 1 million Model 2s and rewritten the rulebook. The reset is live. The EV era has just begun. So, tell me, can anyone still catch up?